In this video, we'll study about normal form of a line. Okay, normal form. See, if we have been given that a line is at a distance of 3 units from the origin. So there are infinitely many lines because there are infinitely many points which are 3 units from the origin. Infinitely many. So there are infinitely many lines which are 3 units from the origin. Okay. But if somebody says that the perpendicular distance of 3 units makes an angle of theta with the positive direction of x-axis, then the lines get fixed. No? So that means if you have been given the perpendicular distance of a line from the center and the angle made by the perpendicular with the positive direction of x-axis, then the line is fixed. So I am taking a simple equation of the line, and perpendicular distance to the line is this. So means what will be given to specify the line? The distance from the origin and the angle made by the perpendicular with the x-axis. Let it be phi. Okay. Now we know if these two things are given, then the line is specific, because there are many lines which are at an angle of which are at a 3 distance unit, and the same way there are many lines whose perpendicular makes angle phi. In fact, this perpendicular belongs to this line also, so this will also make phi, but d and phi given together specifies a line. Okay. Now, so the normal form of a line. How can you find out the normal form of a line? No? Here, as we have been given this and phi. Okay, so this is a right angle triangle here, and we have been given d and phi. That means we can find out the rest side of a triangle. No? In a trigonometry, angle and a side are enough to find out the other measures. Okay, as this is perpendicular, as this is 90 degree and this is phi here, that means this is the base. Okay, and this is the hypotenuse. So from here we can say this base upon hypotenuse is equals to cos of phi. No? That means your OA is actually equals to OP over cos phi, which means D over cos phi. And here in this triangle, this is 90 and this is 90 minus phi, as this full is 90. 90 minus phi. So as this is the angle, okay, then this is your base and this is your perpendicular, and this is hypotenuse. So with this I can find out this. So this is base and this is hypotenuse. So I would say OP over OB is again cos of, but not phi. The angle here is 90 minus phi. So OP is actually equals to D, and this is OB. And cos 90 minus angle is actually sine of phi, which implies OB equals to D sine phi. Now why am I taking out this and this? Because I have to write down the equation of this line, and I have actually got the two intercepts of the line. So I can use the intercept form. You know what is the intercept form of any line? Intercept form is x over a plus y over b equals 1, where a and b are the x and y intercept respectively, and x and y are the general coordinates of the line. So what is the A? Means the x-intercept. So OA is d cos phi, no? D over cos phi, and B is here d over sine phi, which is equals to 1. So which implies x cos phi plus y sine phi is equals to d. Okay, so this is your normal form of any line. Okay, x and y are the general coordinate. Phi is the angle between the normal and the x-axis, means the perpendicular from origin to the x-axis, and d is the perpendicular distance of the line from the origin. See, derivation is important, and once you have derived, you must learn this, and if you are learning this, you must know the meaning of each letter. Only then you can understand your problem sum. No? Now we will discuss how to convert any equation into its normal form, any line into its normal form. Okay, so just keep this in mind. I'm erasing the next. From any form you should be able to convert into normal form. Okay, so I'm starting with the very basic equation which can be convertible to everyone. That is why it's called general equation also. Let me take the equation as x plus y plus 1 equals to 0. This is the equation of a line. We have to convert this into normal form. Converting it to normal form, how does it facilitate? It actually tells us what is the distance of this line from the origin. Means it's ready to look at. It's reveals from the equation that the distance is this, and somebody can easily see what is the angle made by the perpendicular to with the x-axis. Anyway, by just doing these sums from one way and the other way and converting them from one form to the other, we actually increase our insight into the topic. So the thing is, we have to convert this into normal form. Okay, so what is normal form? Basically, your normal form is this: x cos phi y sin phi equals to d. Means here you have a distance of a line from the origin. So what is the distance of this line from the origin? Let's calculate d very first. Okay, so origin, so we know the distance formula is this. So distance from origin is actually, it's 1 into 0 plus 1 into 0 plus 1 over 1 square plus 1 square, which is actually equals to 1 over root 2. So distance is this. Okay, so here what can we do actually? We can shift this minus 1 to that side. Okay, but we don't need minus 1 here. What do we need here? 1 over root 2. So what we need to do? We need to multiply this full equation by minus 1 over root 2. No? So this will become actually minus 1 over root 2x minus over 1 over root 2y, which is equals to plus 1 over root 2. So here what is the angle? C. The cos phi is also minus 1 over root 2 and sin phi is also minus 1 over root 2. Both are negative. So both are negative in third quadrant, and this is root 2. No? So what is your angle? Basically it's 180 plus 45. So 180 plus 45 is your 225 degrees. No? So here we can write that we have x cos 225 degrees plus y cos 225 degrees is equals to 1 over root 2. So this is the normal form of this equation, this straight line. Okay. See, normal can make more than 180 degrees because normal can go in any direction. Means the perpendicular from origin. It will have value in all 4 quadrants. Unlike line where we take the value of angle from 0 to 180 degree conventionally. Okay, let's try one more equation. Suppose we have 3x plus 4y minus 2 equals to 0. Suppose this is the equation. So first of all we have to calculate d. So d is basically minus 2 over 9 plus 16. We take the positive one and this is actually equals to 2 over 5. This is 2, this is plus minus 5, but we actually take the positive value, so 2 over 5. So this is 3x plus 4y equals to plus 2. I'm not writing any statements here, but you must write it. Now here for the normal form we don't want 2, we actually want 2 over 5. So dividing or multiplying the full equation by 1 over 5, what did we get? This, and this. So this is our d. And what is this? This is the value of cos theta, cos phi. Okay, this is sin phi. Now the question is, see, this angle is gonna be same because phi is the angle made by the perpendicular with the positive direction of x-axis. So is there any value of theta which the cos of which gives you 3 over 5 and the sine of which give you 4 upon 5? For sure it is there. Why? Because we are dividing. How did we get 5 here? Just because of squaring this and this, 9 and 3 and 4. No? We squared 3, we squared 4, that's why we get this, and then square root of that 5. That means this is hypotenuse, this is B and this is B in a way. No? And when we will divide P by H and B by H, then we get cos and sine only. No? So here we can definitely say we don't know which angle is that, but yes, there is an angle. No? So so here we can write x into cos of tan inverse 3 over 5 plus y into cos of, sine of tan inverse 4 upon 5 is equals to 2 upon 5. So every equation can be converted into normal form. This can be calculated through calculator. Okay. So this was about normal form. Why am I telling you all of this? Just to enforce that visual matters. If you won't have visual for the normal form, if you leave its derivation even, then you will never able to decode what is phi, what is d, and how to deal with that. Okay, this was a small effort to make you people understand this. I hope you understood. Thank you.